A radioactive isotope decays exponentially. The time it takes for half the amount to decay is called the isotope's half-life. This represents your common ratio. A certain isotope has a half-life of 12 hours. Okay, so the rate is described as the half-life. Now how often that occurs goes on the bottom. If after 72 hours there's this much left, what is the initial amount? We want to know this amount. Okay, so I have a y and an x. Now they say for this particular problem is after 72 hours, we know that 0.425 milligrams remain, and we want to solve. So I can first figure out this part. Notice they're being multiplied, and then divide that quantity to the other side. So 1 divided by 2 raised to the 72 over 12. This is this quantity. A sub 1 times this quantity. So to isolate a sub 1, I want to divide it to the opposite side. 0.425 divided by the previous answer. I end up with 27.2. Okay, hold on. What are they talking about? The initial mass. Mass is in terms of milligrams. Okay, find number 10. Oops, we're still on 9 part B. The half-life of chromium-51 is 4 weeks. If a sample contains 700 grams originally, how much of the chromium would remain after 100 days? Round to the nearest tenth. Okay, well notice that this is in terms of weeks, and then this is in terms of days. So half-life again is described like this. How often does it occur? It occurs every 4 weeks, which I know there's 7 days in a week. 7 times 4 is 28. We're told that the sample contains originally or initially 700, and they want us to solve this after 100 days. So they want to know what is the final answer after 100 days. Notice they're in the same unit here. So I have 0.5 raised to the 100 divided by 28. Take this amount times 700. Okay, and this is round to the nearest tenth. 58 point, I'm not going to write 883. Rounded to the nearest tenth is 58.9.